Cool. Sure. Can you see my slides? Cool, yeah. Perfect. So basically, as I said during the round of presentations, my name is Artem, and I'm working in St. George on a Bike project. Actually, yeah, it's a really interesting project about the artificial intelligence and applying the techniques or the methods of artificial intelligence in GLAMs, especially in museums. And we're working a lot with some big museums here in Spain. We are in cooperation with Europeana. But today I would like to talk not about the project exactly. I would like to talk about the challenges which we met during the project, and I guess it would be much more interesting for the community. Just a couple of slides. I would like to present what we are doing, and in that case, you will be able to understand more precise why the challenge happens and what we have to do with it. So about the project, the idea of the project is to create the methods, the applications using the artificial intelligence, especially especially computer vision and natural language processing for enrichment of metadata. We're not talking about one type of the enrichment of the metadata. I mean, right now you have to understand that I will always talk about the metadata and data in the GLAM, in the museums, in galleries, in libraries, and archives, of course. We are not talking about one type of the metadata. We would like to apply this project for any type of the metadata. It can be descriptions in museums, it can be tags in search engine of web pages of the galleries, it can be some applications for minorities, it can be any kind of metadata where we can improve the interaction between the users and GLAM sites. What was the motivation of the project? As I said, the automatic metadata annotation, because sometimes the metadata which we have right now in different web pages of the museums is not good enough and it's not quality enough. The another way of motivation was the new forms of interaction between users and GLAMs, between visitors and GLAMs. We have to understand that we are in the 21st century, and some cases we have to innovate, to upgrade our ways of interaction between the users, and the sites. Another way of motivation, another form of motivation was interaction with minorities, such as visually impaired citizens. And I guess it's really important to integrate these minorities in possible cooperation with GLAMs in the future. And of course, improving search engine, for example, for web pages or some kind of applications. I just want to give you the brief what we have done for now. So basically, the idea of the project was to create the pipeline of several aspects, of several approaches, which will be able to enrich metadata based just on the image. So basically, we have, for example, we have the painting. We apply our pipeline for this painting, and the pipeline will generate, for example, the caption in natural language, several tags, the main understanding of scene, relationships between objects, and all of this stuff. So basically, for now, the pipeline contains like several steps, and we decided to start from the object detection. Based on some types of the artificial neural networks, where we detect the main objects of the paintings. Then we applied the NLP techniques for description generation, and right now we're able to generate the simple triplets. We call it triplets. Basically, it's kind of like the man on the horse, or the man is riding the horse, or the man is holding the lance, the man is holding the sword, or monk is standing in front of the crucifixion, or I don't know, bishop is praying, something like that. So it's not like a full description where we describe every single element of the painting, but we will do it in the future, of course, and we will be able to achieve it. The third component is visual relationships. So we are trying to understand the visual relationships between several objects on the paintings. So for example, if the person holding something, or I don't know, the person is riding, or the person is standing, or the person is standing in front of the building, or something like that. And there are like really small steps, which is description classifier and improving object detection based on the time context. Caption classifier is the idea of caption classifier based on the extraction of the relevant metadata. So basically, when we try to train the model, to train the artificial neural networks for object detection or for caption generation, we try to collect a lot of data from different sources, from Europeana, from several museums. We connected with several museums in Netherlands. But the point that the quality of the metadata is really poor, is really bad. Because in some of in most of the cases, the metadata contains information about the author, about the medium, about the place where the object were found, about the, I don't know, the style of the painting. But this metadata is not relevant for the theme, for the idea of the painting, what's going on in the painting. So the description classifier tries to extract the relevant metadata from the scope of the data, especially for each painting. And improving object detection based on the on-time context is an idea when we fix the neural networks to be able to understand that for example, for like 15th century, it's impossible to detect the helicopter on the painting because we understand that there wasn't any helicopter. And we try to explain to the neural network this approach, and it works. But yeah. So it's more like technical questions about how we did it. And if someone interesting, I would be super happy to answer for your questions in the future. But today I would like to focus on other type and other side of the project on St. George and Bike. Here you just have some examples of object detection. On the left side, on my left side, yeah. You can see the example of object detection, the neural network, which were based on the COCO dataset. And on the right side, you have example of our neural network for object detection. Here are some examples of different paintings where we try to detect the objects. I mean, I just found it interesting and I decided to show you. For now, I mean, it's just for information. We have like 69 classes of objects, and these 69 classes is related especially for the cultural heritage domain. So there is no helicopters, phones, frisbees, and all of this stuff. All of these like 69 classes is related to the paintings like related to the cultural heritage objects. What we will do in the future. So basically, we are trying to improve our current methods to be able to achieve the good accuracy and to be able to deploy this approach in production. We will try to implement some search and browse functionalities for the future, and to be able to find, like, to develop the search engine and share this search engine, for example, for GLAM sites where like everyone can apply it for the web pages or applications. We will try to collect more data. We will make the proper evaluation and some experimental ideas about builds of knowledge graph for cultural heritage domain, and use this knowledge graph for future detection of relationships and understanding of the scenes of the paintings. This is about St. George on the Bike project. Basically, I finished, and if you would like to ask some questions, I will be happy to answer. But today I would like to talk about some challenges. I decided to split my presentation for two parts. One part is challenges of the St. George on the Bike project, and second part is the challenges which we found in applying artificial intelligence for cultural heritage domain. This is two parts. They're connected to each other because they're related to each other. And the idea of this presentation was to discuss these challenges and try to find the solutions for them. I mean, obviously not today, but we would like, as a St. George on the Bike project team, we would like to start the discussion in the community because we think that it's really important. What we figure out when we are working in St. George on a Bike project? First of all, the problem is data collection. If we will look precisely in applying, for example, artificial intelligence in medicine, we will be able to understand that it's much easier because even like there is no like proper data for training the models or training the artificial intelligence models, we will be able to generate this data. What I'm talking about, for example, like we decided to train the model which will be able to detect the cancer on the X-ray screenshots. And it's pretty easy, to be honest, because we have to collect the data, we have to train the neural network, and if we will understand that the neural network has a better accuracy, we will like keep going to collecting the data, and we will add this data to be able to improve the accuracy of the model. This is the problem for cultural heritage. We are not able to generate new data because if we would like to train the object detection model for the paintings, we have to understand that we have limited number of the paintings, and we will not be able to generate new paintings. I mean, basically, yes, we are, but the process of generation is really hard. We tried different approaches like synthetic generation of the paintings. We tried some approaches of converting the photos to the paintings, but it's not good enough because we have to understand that the paintings and cultural heritage objects, they have like specific features like a style, medium, color. They can differ significantly between the artists, and we have to take into account this. The second point is that the cultural heritage objects, they don't represent real life. What I'm talking about? I'm talking about the unicorns, Minotaur, witches, wizards, such kind of like supernatural beings which can be seen just in a cultural heritage objects. We cannot see these objects in real life. So the problem that we cannot generate new data for these objects. Basically, we have to use the data which we have right now, and it's just few examples where we understand that unicorn is a horse with a horn, where the the Pegasus is a horse with the wings. But these ideas can be changed from the time to time. And for example, right now there are a lot of different like stylish unicorns which we cannot use as data for training of the artificial intelligence methods and approach for cultural heritage domain. The second point is small data sets of the paintings, and it was the problem, and it's the problem right now as well, because during the whole project we were able to collect just like 15,000 of different paintings, and it's not good. It's not enough for the training of the model, because we understand that we would like to train the proper model with good accuracy, with good precision. And even like using the specific techniques of like transfer learning, but even with these techniques, we will not be able to achieve good accuracy. The third point is poor metadata. As I told before, even like in data aggregators such in Europeana, Web Gallery, Wikiart, the metadata is not good enough for the training of the models of artificial intelligence, because it's not related to the painting. It's related to the artist, it's related to the painter, or I don't know, such kind of things. And yeah, evaluation. It's a challenge because we have lack of data, as I told before. These challenges is related to the St. George on the Bike project, and we made it during the process of like collection of data and trying to try different approaches for cultural heritage sites. But we understood that these challenges are related to bigger challenges, which can be related to cultural heritage domain in general, not just about the St. George on the Bike project. And actually, I would like to talk about these challenges for discussion today. And we would like to start the discussion in the community to be able to understand if it's possible to solve it, if it's interesting for the community, if it's really important or it's not important, and it's just our opinion. So basically what I would like to share with you today. The first challenge is data accessibility. I know just a couple of aggregators which collect the data of cultural heritage sites. And yes, I mean, we can access this data, we can use this data, but first of all, you have to understand that that due to the lack of data in cultural heritage domain, all available data should be accessible. What I'm talking about, for example, some museums try to share their data, to publish their data on the web pages. I mean, it can be the photos of the paintings, it can be photos of the cultural heritage objects, but we cannot access this data. So we can open the web page, we can check the catalog, we can like see the photos of the paintings, but for example, we cannot download these images, or we cannot download the metadata about these images. Because there is no API. The web page is not user-friendly, especially like for open data case. There is no like proper metadata on the web page, and actually it's a big deal for such projects like St. George on a Bike, because we have to create the scrappers for each site and to scrap almost manually each painting. The second challenge is Creative Commons license. It's not a challenge like it sounds, but what we figure out that there are a lot of museums which decided to share the data on the web page, but it's not under the Creative Commons license. And we can, for example, like scrap this data, we can download this data, but we cannot share this data in the future. Basically, the data set which we created right now for the object detection, we would like to share this data set in the future. And everyone could like have access to this data set to train their own model and to be able to use the artificial intelligence for like their own proper task. But we cannot do it because some of the museums, their data is not under the Creative Commons license. And we have to understand how this question can influence the applying artificial intelligence in the cultural heritage domain in the future, because the data is a key, is a blood of the artificial intelligence, and you know this kind of like strange words, garbage in, garbage out. So if we have like the bad data for the artificial intelligence model, for training the artificial intelligence model, we will receive the bad model in the future. And I guess this point is a key point for developing the artificial intelligence in cultural heritage. And like from this point, we have to understand that this point is stopping the developing and the applying artificial intelligence in cultural heritage. The third point is data quality. So as I told you like several times during this presentation, we have to understand that the quality of metadata should be relevant for the images. In that case, we have to understand the type of metadata, the quality of the image, the size, the resolution of the image, the structure of the data, and all of this stuff. So basically, what we figure out that, for example, like in some data aggregators, the metadata, the description of the paintings can be like just cut it, because they are not care about the quality, they are care about the quantity. So they are just trying to collect as much as possible data. They don't check the quality of the data, and some descriptions, for example, can be cut it. Some tags can be irrelevant, and in that case, we have manually to check like almost every description to be able to include the description in a future training process. Again, as I told before, the problem of lack of data. So it's related for some classes, some objects. It's related for some styles, some mediums and colors, and we don't have a lot of paintings at all, and it's key point. So that's why we have to understand that all available data, all data which can be generated by the GLAM sites should be available, just to be able to push the development of the artificial intelligence in cultural heritage domain. And the last point, databasing. It's really sensitive topic, actually. And I would like to start discussion about it because it's really interesting for me. And I'm not sure that it's super relevant, but anyway. In pipelines of development of artificial intelligence models, there is a step which calls model validation. During this step, normally the data scientist or the specialist in artificial intelligence, they validate the model, how it works. They try to calculate the accuracy, the precision, such kind of steps, such kind of things. But last time we started to calculate the fairness. It's pretty new metric, but it's really important. Let me explain what does it mean. For example, we decided to train the model, which detect the person on the image, random image. It's not about the paintings. We are talking about like general images right now. This model can detect the person. The fairness means if the model will be able to detect the person, if the fairness is the metrics when the model will be able to detect the man and the woman with the same accuracy. Or, for example, like...
Sorry to interrupt you. I just want to make you aware of time, that we're only like running short on time. It's like 10, well, it's 48 to the top of the hour. So we only have like 12 minutes left. So if you want to have a little bit more of discussion, could you please run it up? So
okay.
Yeah.
Just a couple of minutes and I will finish. So about the fairness. So when we are trying to evaluate if the model is fair enough for each kind of the group of the objects inside of the model. So, for example, if we are talking about the person, it should be equal to detection of it should be same for detection of man and woman. We can talk about like race. We can talk about the nations. We can talk about some kind of sensitive stuff. And during the collection of the data for this project, for St. George on the Bike project, we figure out that it's really difficult to support the fairness because of the representation of different aspects of this fairness. And again, it's this point coming back us to the problem of the limited data and lack of data, and we have to take into account this again in the future steps of like discussing of the accessibility of the data. Okay, let's stop here. I understand the next slide is really interesting, but yeah, let's stop here and we can discuss some points which I presented right now. And if you have any opinion, if you have any ideas, I would be glad to hear you and just let's talk.